Let's calculate the average and standard deviation for a sample set. So we were looking at statistics, numbers that describe a sample. To find my average x bar, I take all of my numbers and I add them. That's what this symbol means. Whenever you see this, this means that you're adding things. And then I'm going to divide it by the number of terms. So in this case, I have 1 plus 5, and I'm adding all these things up. And counting it out, it looks like there are 7 numbers. When I divide by 7, I get something like 6.714 or so. And that seems reasonable. That feels like it's a weighted center that's close to my median of 6 or so. The variance describes the gap size from each of the values to the center. So variance, my s squared, this is going to add each of the individual values, 1 minus the center, square. I'm going to add these up until I get to the last number, 12 minus 6.714 squared. So what I'm doing here on the top of this expression is I'm trying to figure out what the gap size looks like from the values to the center, because the variance is telling me something about the spread, how far apart these things are. I'm going to divide this by the number of gaps. So what I mean by that is if I have 4 values, I would have 3 spaces between it. If I have 3 values, I have 2 spaces between it. The variance looks at, sample variance looks at the spaces between. So you could count the commas, for example, 1, 2, 3, 4, 5, 6 commas, or you can just know that it's going to be the number of values minus 1. I'm going to type this into a calculator, and I will see what I get. Now, sometimes when I type this into a calculator, I break this up into small steps. It's totally okay. I'm just going to go for it. I got 13.238. Now, looking at this, does not look like my average gap size is 13 because my smallest value is 1 and my largest value is 12. So that's even larger than my range. And that's because that's not my average gap size. My standard deviation gives me something much closer to that. And to find my standard deviation, I have to take the square root of the variance. So I'm going to take the square root of this 13.238 number. And when I do so, I get a standard deviation of about 3.638 or so. And that seems much more reasonable given my data set. So if I'm comparing each of these individuals to 6 or so, on average, they have a gap size of around 3.638. And that's how I find my sample standard deviation and my sample average.